To understand circular motion, we should know what is angular displacement, then what is angular velocity, angular acceleration. So in this video, I'm going to explain one by one. First, let us see angular displacement. A particle is there at this point. Suppose the particle is going from A to B. Then an angle is described. The angle described at the center of the circle is known as angular displacement. The line joining the center of the circle to the particle is called radius vector. So this is a radius vector. When it is going from this position to this position, radius vector is sweeping an angle. That angle is what is called angular displacement. So we can define angular displacement as the angle described by the particle about the axis of rotation or at the center. Now this angle theta is equal to AOB. This angle AOB. Angle is measured in radian. SI unit of angle is radian. Then you know, when angle is expressed in radian, this angle can be written as theta is equal to S by R, where S is the arc length. This arc length, S. So theta is equal to S by R. After rearranging, you can get S is equal to R theta. Here theta is called angular displacement. S is called linear displacement. So this angle is angular displacement. Suppose a boy is running and starting from here and he is completing one full circle. Then his angular displacement is 2 pi radians. Then this total distance, circumference of the circle is 2 pi r. For this S, you can write when boy is completing one full round, this S is 2 pi r. Then you divide by the radius. So this r will get cancelled. So when a particle is completing the full circle, angular displacement is 2 pi radians. Then here you can see S is equal to R theta. Now first, suppose a boy is running in a circular path of radius 7 meter. So in this radius, you can write a 7 meter. Then when he is completing the full round, angular displacement is 2 pi. So 7 into 2 pi. For pi we can substitute 22 by 7. Then the 7 will get cancelled. So 2 into 22, that is he is completing 44 meter. Suppose another boy is running in a circle with radius 14 meter, double the radius. Here first boy is running in a circular path of radius 7, second boy is running in a circular path of 14. So now radius is R2. First one radius is R1, second radius more. Now you substitute for this pi. So now 14 and 7 will get cancelled. So 2 into 2, 4 into 22, 88 meter. See now its linear displacement is different. First boy is completing 44 meter when he is running. The second boy is running in a circular path with radius 14. So he is completing 88 meters. So linear displacement is different, but angular displacement is same, 2 pi, because the angle made at the center of the circle is 2 pi radian. Suppose a boy is going from here to here, then angular displacement is pi by 2 radians. Suppose he is going from here to here, it is pi radians. So angle made at the center of the circle is what is called angular displacement. Now let us see what is angular velocity. Angular velocity is the rate of change of angular displacement. Suppose a body is going from one position to another position, then this change in the angular displacement, let it be delta theta. You divide it by the time interval delta t. So it's a rate of change of angular displacement. So average rate of change, total change in the angular displacement, you divide by the total change in the time. So this is the angular average angular velocity. Then for getting the instantaneous value, limit delta t tends to 0. So this change in time interval is very small. Delta t tends to 0. Then delta theta by delta t is d theta by dt. Then you will get the instantaneous angular velocity. So angular velocity is the rate of change of angular displacement. Then angular displacement is measured in radian, time is measured in second, so angular velocity is measured in radian per second. Then suppose a particle is going in a circular path, then so this is the direction of the angular velocity. This is radius vector, so linear velocity. Then this is the angular velocity. Direction of the angular velocity is perpendicular to this. Angular acceleration is the rate of change of angular velocity is called angular acceleration. So d omega by dt. Angular acceleration is denoted by the letter alpha. Then it is measured in radian per second square. Thank you for watching.